Hello viewers on YouTube. In this video tutorial, we're going to focus on rectilinear motion. So get your pen and your jotting notes to jot down some few points. So a rectilinear motion is the movement of an object from one place to another on a straight line, from the word linear. And now this motion is specifically represented in form of an equation as S equals f of t, where s is the displacement of the particle or of the body, while t is the time taken to move from one point to another. Now, since we know that velocity v is the rate of change of displacement, then mathematically velocity v is simply the s by the t, which means if we have the displacement of a particle as a function of time, then differentiating that displacement gives us the velocity of that particle. Now, you notice that acceleration A is equal to the rate of change of velocity. So we can clearly say that the acceleration is the derivative of the velocity with respect to time. And since v is the derivative of distance with respect to time, then therefore we can clearly say that the acceleration is the derivative of distance or displacement with respect to time. Now, if this bracket is expanding, you notice that the acceleration will now become the second derivative of the displacement function, and this can be read as d squared s by dt squared. So which means if you have the displacement function and you are required to find the acceleration, then the derivative is expected to be done two times or twice. While if it is distance, if it is velocity you are required to find, then the derivative is expected to be done once. And if it is a velocity function you are given, then to find the acceleration, you are just to differentiate it once. So please be very, very careful in identifying or in concluding whether you are differentiating once or not. Perfect. Now, it is important for you to understand the behavior of the s dt, which is the velocity, and the squared s and to t squared, depending on the problem you're dealing with. When a particle moves away from a particular point O, then it is important to understand that the s dt would be greater than 0 in this case. And when a particle moves toward point O, then in this case the velocity ds dt will simply be less than 0. And the final case is when the particle is momentarily at rest. Then at this point, the s dt will simply be equal to 0. These key statements are very, very important. This is when the particle is moving away from a particular point, and these occurs when the particle is moving towards a point, and these occur when the particle is not moving, it's momentarily at rest. Perfect. Now, if the velocity of the particle is increasing, then we say that the v dt is greater than 0, which simply means that the particle is accelerating. Also, if the v dt is less than 0, then the velocity is decreasing, and this simply means that the particle is decelerating. But if the v dt is equal to 0, then it means the particle is moving with a constant velocity, no deceleration, no acceleration. So these are the key points and the things you have to be familiar with while dealing with problems involving rectilinear motion. So let's make good use of all this by considering some examples. On to example number 1. The motion of a particle along a straight line is specified by s equals 4t to the power of 4 minus 3t to the power of 3. Find the velocity and acceleration after 3 seconds. So, solution. The displacement s is given as a function of time as 4t to the power of 4 minus 3t to the power of 3. So the goal is to find the velocity v and the acceleration a, but not just finding them, but their magnitude when the time is 3 seconds. So these are the likely questions you might encounter while dealing with rectilinear motion problems. So let's differentiate the displacement particle with respect to time. So this gives us 16, that will be 4 times 4, t to the power of 3, we subtracted 1, then minus 3 times 3, t to the power of 2, which is indeed equals to 16t to the power of 3, minus 3 times 3, that's 9, minus 9t to the power of 2. Perfect. So now that we have the derivative or the first derivative of the displacement with respect to time, since we know that that is equal to the velocity, we can determine the velocity after 3 seconds. So the goal is just to substitute t equals 3. So when v equals 3, v equals 16 times 3 to the power of 3, then minus 9 times 3 to the power of 2. Now simplifying this forward, the velocity v becomes 16 times 3 to the power of 3 is 27. So we have times 27, then minus 3 to the power of 2, that's 9. So minus 9 times 9. Okay. So 16 times 27, if I use my calculator for that, I got 432. Then 9 times 9 just gives us 81. And if we subtract 81 from 432, then we got 351 meter per second. Velocity is measured in meter per second, and that will be our velocity after 3 seconds. Now, what about the acceleration? To find the acceleration, we need to differentiate the velocity function, or we should differentiate the distance or displacement function 2 times the second derivative. But let's just find the v dt straightforward. The v dt is simply equals to 16 times 3t, 3 minus 1 gives us 2, is to the power of 2, then minus 9 times 2, t to the power of 1. 2 minus 1 gives us 1, so I'm just writing t alone. So we have 16 times 3 gives us 48, t to the power of 2 minus 9 times 2 gives us 18t. So at t equals 3, just like before, the goal is just to substitute t as 3. We will find t in the v dt. So acceleration a is now equal to 48 times 3 squared minus 18 times 3. So 3 squared, that gives us 9 times 9, then minus 18 times 3. So the product of 18 and 3 would give us 54. And therefore, for the product of 48 times 9 gives us 432. So 432 minus 54, what would that be? So that results in 378. And that is our final answer to the acceleration of the particle after 3 seconds. And this is how to easily solve problems involving rectilinear motion. On to example number 2 for easy understanding. The motion of a particle starting from O is described by the equation S equals t to the power of 3 all divided by 3 minus 7t squared divided by 2 plus 10t. How far is the particle from O? When the particle is momentarily at rest. It is important to understand two most often used statements, and these statements include how far and how long. Well, in this problem, it is how far that is used, but there's another one called how long. Whenever you hear the word how far, think of distance or displacement. While wherever you hear the word how long, then think of time. So which simply means if you are to find how far, then you are required to find the displacement of that particle, and if you are to find how long, you are required to find the time taken for that particle to complete a particular task or mission. So please keep that in mind. So let's write the displacement function. So S is given as t cubed divided by 3 minus 7t squared divided by 2 plus 10t. So the goal is to find the displacement when the particle is momentarily at rest. Let me use this to show that. When it's momentarily at rest. Now, when a particle is momentarily at rest, we said the velocity will simply be equal to 0. We said this at the beginning of the video that the s, the t, would be equal to 0. And that can always help us to determine the value of the distance when the velocity is 0. So let's find the s, the t, and now set it to be equal to 0, and then solve for the distance at that point. So therefore, we said the s, the t is equal to, so when this comes, we have 3t squared over 3, then minus 7 times 2t over 2 plus 10. So the 2 reduce, likewise the 3. So therefore, the s, the t is equal to t squared minus 7t plus 10. So that is the displacement, the derivative of the displacement function. So the goal at this point is to set the s, the t to be equal to 0. So when the particle is momentarily at rest, according to this statement, then the s, the t will be equal to 0. And therefore, t squared minus 7t plus 10 equals 0. Okay. So now, as you can see, we have a quadratic equation with variable t plus 10 equals 0. So the goal is to find the value of t when the particle is momentarily at rest. So having gotten the value of t when the particle is momentarily at rest, since we have the displacement function, we can use that to find the displacement when the particle is momentarily at rest. So that's also what we're trying doing. So let's factorize this trinomial. So what two numbers add up to -7 and multiply to 10t squared? Well, that will just be 5 and 2. But if you don't really know how to get the 5 and 2, this is the logic I usually use. So I start by using 1 multiplied by what I want to know, two numbers that will multiply with it. So 1 times 10. 1 times 10, these are two numbers, and when I multiply them, it gives me 10. Now I will now move to the next number after 1, that's 2. Can it reduce 10 without remainder? If it is, then I will proceed forward. But if it's not, I'm getting rid of it and move to the next one. So you notice that 10 divided by 2 gives us 5. So we are using 2 times 5. To the next one, 3. 3 cannot reduce 10 without remainder. Cancel that. 4. 4 cannot do that. Cancel that. 5. 5 can do that. But 5 has already showed up. So you stop. So when you get to a point and that point already shows up, that shows that you have exceeded all the limits, all the values that can work for having just two numbers that will multiply to that number you are trying to simplify. So then you will begin testing what you have. As you can clearly see, 2 and 5 has already shows up, and that can definitely help us to get 7 and 10. The goal is just to attach the appropriate sign to them. Since you are looking for -7, you can set -2 minus 5. Since the product of -2 minus 5 gives us +10. So that's how it works. If we encounter any other one, we use the logic to get the two numbers. So let's move on. So we have t squared minus 2t minus 5t plus 10 equals 0. The goal is just to associate the variable to the two numbers you got and then replace them with the middle term. So we now have, put it in the parentheses, t squared minus 2t, then in the bracket again, minus 5t plus 10 equals to 0. Okay. So therefore we now have, let's factor out some common values now. T in the bracket of t minus 2. Then for this one, negative 5 is common. Minus 5 in the bracket of t minus 2 equals 0. So taking out the GCF, we have t minus 5, t minus 2 equals 0. So set each of them to be equal to 0. T will be 5 and t will be equals to 2. Since t minus 5 equals 0 and t minus 2 equals 0, you know, t will just be equal to 2 right here, not 0. When the 2 comes, when the negative 2 comes, it becomes 2. So when the particle is momentarily at rest, the time is 5 seconds and 2 seconds. Now the goal will just be to find the corresponding displacement at each of these points or at each of this time. So when t is equal to 5, what will be the displacement? That's what we are doing. So s will be equals to 5 raised to the power of 3 divided by 3 minus 7 times 5 all squared divided by 2 plus 10 times 5. Oops. So 5 to the power of 3 is 125 divided by 3 minus 5 squared is 25, and we have 7 times 25 divided by 2 plus 10 times 5 is 50. Okay. This can go, we don't need it anymore, but the time are still necessary. So t is 5 and t is 2. So we have 125 equals to the distance or displacement, 125 divided by 3 and minus 7 times 25, that gives us 175 divided by 2, then plus 50 divided by 1. So the LCM, let's consider that to be 6. And then we have 3 and 6, that gives us 2. 2 times 125 so gives us 250. The minus 2 and 6 is 3 times 175 gives us 525. Then 1 and 6 gives us 6. 6 times 50, that gives us 300. So if we add all these numerators up, we got 250 minus 525, then plus 300. So I got 25. So we have 25 over 6. So therefore, in mixed number, the final answer would be 4 whole number, as we can have 4 6 in 25, then that will be 1 over 6. So that is the displacement of the particle when the particle is momentarily at rest. But that's when the time is 5 seconds. But notice that the particle is still momentarily at rest when the time is still 2 seconds. You understand? So let's find the distance as well when it is 2 seconds. So we are getting rid of all this right now and then find the displacement. So when t is equal to 2, s equals to 2 cubed divided by 3 minus 7 times 2 squared divided by 2 plus 10 times 2. So that becomes 8 over 3, 2 cubed is 8, minus 7 times 2 squared is 4, that's 7 times 4, divided by 2, plus 10 times 2 is 20, right? So we have 8 over 3 minus 7 times 2, that gives us 28, 7 times 4 rather, then divided by 2 is 4, then plus 20 over 1. LCM is still 6, then this displacement we are solving for. 3 and 6 is 2, 2 times 8 gives us 16, minus 2 and 6 is 3, 3 times 28 gives us 84, then plus 1 is 6, 6 times 20, that gives us 120. So when we add this up, we have 52. So the displacement equals 52 over 6. And just like before, in mixed number, we have displacement to be, so how many 6 can we have? 52, that would be 8. Then whole number 2 over 3. So that would be our final answer to example number 2. So the corresponding displacement when the time is 5 and 2 seconds respectively is 4 whole number 1 over 6 and 8 whole number 2 over 3 respectively. On to example number 3. The motion of a particle starting from O is described by the equation s equals 2 to the power of 3 all divided by 3 minus 17t squared divided by 2 plus 21t, where s is the displacement in meters and time t in seconds. Find the acceleration of the particle when it is momentarily at rest. So therefore, the first thing we have to consider doing is to find the s dt. When a particle is momentarily at rest, the s dt is equal to 0. Then we find the time at that point. So what will be the s dt? Since s is equal to 2t to the power of 3 all divided by 3 minus 17t squared divided by 2 plus 21t. So the s dt will be equals to, when the 3 comes down, we have 2 over 3 times 3t squared, the minus 17 over 2 times 2t, then plus 21. The s dt equals 3 reduce, 2 reduce. So we have 2t squared minus 17t plus 21. So this is the velocity of the particle. So when the particle is momentarily at rest, according to this statement, the s dt is equal to 0. Therefore, 2t squared minus 17t plus 21 will be equal to 0. So now we find the time at this point. So we need two numbers that multiply to 21 times 2 and that at the same time add up to minus 17. So what is 21 times 2? That gives us 42. So we are using 42 this time around. So let's begin by saying 1 times 42. So 2 can work. That's 2 times 21. Can 3 work? Yes, 3 can work. So we have 3 times 3 in 42. That gives us 14. Can 4 work? 4 cannot work, it's sure. Now what about 5? 5 cannot work because it's not a multiple of 5. Then 6. Let's see 42 divided by 6. Yes, that can definitely work. So we have 6 times 7. Now when we get to 7, 7 has already shows up. So we have exceeded all the limits, or all the values that can work. So the goal now at this point is to find the two numbers that can add up to 17. All of them can all multiply to 42. This can never add up to 17, neither can this, nor can this. But this other one can definitely work, as 3 plus 14 gives us 17. So I can just attach minus to it, because I want minus 17. And that is how the logic works. I hope we now know how to use it properly. If we see a counter situation like that, we will still consider using it. So let's replace minus 17t with minus 3t minus 14t. So we have 2t squared minus 3t minus 14t plus 21 equals 0. So now let's put them within the parentheses. So we have, let me use different color so that you won't mix them up. 2t squared minus 3t and minus 14t plus 21 equals 0. Keep in mind, the arrangement is irrelevant. Either it is 3 that is here or 14 is here. It doesn't mean. You'll be able to factor it. So we have For this one, t is common. Let us say t is common for this first bracket. So we have t in a bracket of 2t minus 3. While for this one, let's take minus 7. Minus 7. Then we have 2t minus 3 as well. Equals, notice, minus 7 times minus 3 gives us 21. Minus 7 times 2t gives us 14 minus 14t. So taking out the GCF, we have t minus 7 multiplied by 2t minus 3 equals 0. So now the goal is to solve for the corresponding value of t's. So we have t minus 7 equals 0 and t becomes 7. Also we have 2t minus 3 equals 0. Then adding 3 to both sides, we have 2t equals 3. And dividing 2 by 2, we have t equals 3 over 2. So the time is 7 seconds and 3 over 2 seconds respectively when the particle is momentarily at rest. But the goal was to find the acceleration at this point, not the distance or displacement this time around. It means we need to find the function of the acceleration. So we need to differentiate the particle one more time, or we need to differentiate the displacement of the particle one more time. So there's the t, we got that to be 2t squared minus 17t. Let me write that again. We said here's the t is equal to 2t squared. I'm using this one right now, okay? The minus 17t plus 21. So therefore, d squared s, the t squared, which corresponds to the acceleration, it becomes 4t, then minus 17. After finishing this entirely. Perfect. So at t equals 3 over 2 and t equals 7, we want to find corresponding values of a. So these can go entirely. We don't need the minimum. So when t is 3 over 2, a equals 4 times 3 over 2, then minus 17. So the 2 reduces this 4, and 2 times 3 gives us 6 minus 17. And we end up with negative 11 meter per second squared. So when the t is 3 over 2, the acceleration is minus 11 meter per second squared. Now when t is 7, a will be equals to 4 times 7 minus 17. So 4 times 7 gives us 28 minus 17. And if we subtract this, we got 11 meter per second squared. And that is the acceleration of the particle when the particle is momentarily at rest. By now, you should have been getting used to the logic of solving problems involving rectilinear motion. For easy understanding and to ease your confidence in this topic, let's consider one more example before we end the video. On to example number 4. A body is projected vertically upward, and the height h reached after time t seconds is given by h equals to 1960 minus 4.90 squared. Find the time taken, that's option A or Roman figure 1, to reach the maximum height. Then Roman figure 2, find the maximum height reached. So first thing first, let's write out the displacement. This one is given as in terms of height. So h is equal to 196 t minus 4.9 t squared. So now the goal is to find the time taken to reach the maximum height. When the particle is at the maximum height, then the velocity will be 0, because that's when it will be about to start falling back. An object is projected upward. When it reaches the maximum height, the velocity of that object will become 0, and then it becomes falling back. You understand? So therefore, the goal is just to find the h, the t, which gives us the velocity of our object, and then we set it to be equal to 0. Then we find the time at that point, and that gives answer to Roman figure 1. Perfect. So let's do that. So what will be the h dt? You notice that will be 196. So we differentiate this, that will just be 196 minus 4.9 times 2 t. So we subtract 1 minus t, and now becomes 196 minus 4.9 times 2 gives us 9.8 t. Perfect. So this is the derivative of the height of the particle, which gives us the velocity. So when v equals to 0, 196 minus 9.8 t equals to 0. And then if we take this to the side, we have 9.8 t equals to 196. And since the goal is to solve for t, we can divide through by 9.8. Then we have t equals 196 divided by 9.8. Alright, t will be equals to, so the division of that, what would that result? Notice that will be equals to 20 seconds. And this should also be 9.8. 9.8. Perfect. And that is the time taken for the particle to reach the maximum height. Homework figure 2. We have to find the maximum height reached. Well, to find that, we just need to plug in the time we got in homework figure 1 into the height function. So what would that be? Keep in mind, t is 20 seconds. So height will be 196 times 20, then minus 4.9 times 20 squared. So 196 times 20, I need to use my calculator for that. 196 times 20, I got 3,920. Then minus 20 times 20 is 400. So if we multiply that with 4.9 times 400, we have 196. Is it? So if we subtract the answer from 3,920, we got 196.0 meter. So that is the maximum height rate for the particle when it is projected vertically upward. And that is the solution to example number 4. So hopefully now you know how to solve problems involving rectilinear motion. Thanks for watching. See you in the next video. Feel free to subscribe if you want to. And this is your exercise. So you can always share your solution via the comment section below. Bye for now.